Oh, 2.13, 2.14 quiz, I think. Yeah, yeah. 8 questions, nice, easy, calm questions. Um, what is present in the circuit diagram above? Two resistors in series? No, they're in parallel. Light bulbs in series? Yes, they are in series. Jamba, they're beside each other. Resistors in parallel? Yes, and they're in parallel. Connecting wires? Yes. Ammeter? There is no ammeter here. Here, question 2. It's given you have current is 0.2. They told you the EMF is 3, with the potential difference is 2.8. Yani there's 0.2 volts lost, right? The circuit is closed for 1 minute, so they gave you time. The energy per coulomb that is lost is what? See, some people here they'd be like, "Yo, what's this? Show energy per coulomb." Energy per coulomb is W divided by Q, and this is actually equal to V. Remember W equals QV. Take Q to the other side, you're gonna get V is W over Q. So joules per coulomb is just a fancy way of saying volts. How much volts is lost? We know it's just 3 minus 2.8, which is zero point 0.2. The amount of charge that flows in 1 minute is whatever. Q, the charge, is equal to the current times the time, right? Or in this case, the current is 0.2. With the time is 1 minute, so 60 seconds. It has to be in seconds. You're gonna get 12. The total amount of energy lost as heat is how much? Energy is equal to QV, right? If you have power, then it's power times time. But so we don't have power, we have a charge and we have the voltage. We want the energy that's lost as heat. Energy lost as heat is يعني نحن we lost 0.2 volts, and when you lose volt it's because يعني usually due to heat. Okay, and if we're losing it to heat, we can find how much energy we lost يعني doing that using W equals the voltage 0.2 times how much charge was flowing in that instant, right? Now we found that the charge is 12. So you're gonna get 2.4. That's it. That's pretty much it. When they ask for the energy lost, you just multiply how much volts you lost by the current in the circuit. Here, they asked what's the energy supplied by a generator to transfer a coulomb of charge from the positive to the negative. It's the EMF, right? I got this wrong in the exam because they worded it differently. They said, what is the total amount of energy that is converted in a battery? Converted in a battery is EMF. Okay, that's EMF. As long as you're speaking inside the battery, it's always EMF. Here they're saying from the positive to the negative terminal. It's the battery. عندك البوزيتيف عندك النيجاتيف. Here they're talking about going from the positive to the negative. That's EMF. You're still inside the battery. As long as you're still speaking about inside the battery, then it's EMF. Here the diagram shows two resistors they're in series because they're beside each other, and the bulb is akid in parallel, right? Which of the following is true about electric current? Measuring the electric current. The current through an element is measured with the same device that you used to measure the potential difference. Of course, no. The measuring device must be connected in series. Yes. The ammeter, remember, you have to connect with series. The measuring device must be earth. No, we don't have to earth it. The current is measured by an ammeter. We know this. The measuring device must be connected in parallel. No, it has to be in series. They didn't ask about the voltmeter. Let me go to ammeter. Measuring current. Hold up. An ammeter should always be included in series in which the current is to be measured. The polarity must be respected. This means yani connected with positive with a positive, negative with a negative. The ammeter is used to measure current. When reading it, you must minimize the parallax effect. I forget about the parallax effect, but yani in case they ask it parallax effect, then it's when you look at it in a straight way. Don't look at it like from a bent direction. A voltmeter is used. This is now for the potential difference. And between 2 points, you have to connect it in parallel. But if it's one circuit, make sure to connect the points you want to measure. La 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 la. Yappity yap. Okay, didn't ask for potential difference. Remember that the potential difference, you always use voltmeter. In order to measure the current through bulb A, the ammeter must be attached to point. Let's see. Here we have the current goes from the positive terminal, which is the longer side of the battery, right? So it starts here. It flows through 2, goes to 3. When it reaches 3, it branches off like this and branches off like this. It connects here. We want to measure the current of this bulb. So either you can place it here or you can place it over here, right? And there's no option to place it, like there's no 2 point. They're saying in between 2 points. You can't place it in between 3 and 4 because يعني that would be in parallel, right? It won't connect the bulb. So where are we gonna place it? We're gonna place it in between 4 and 5 over here. So the current continues here, it reaches, and we just measure the current after it went out of the bulb. So that would work between 4 and 5. Because 3 and 4, it would go out. We don't want that. You remember for a current, the ammeter, it has to be parallel. Else it has to be series. Okay, so that's why you can't use 3 and 4 because then it would be parallel. So it would be 3, you'd use 4 and 5, and obviously it has to be series. Then to measure the PD across bulb B, you would connect it in parallel. PD is the easiest one. You just take it outside like this, and you put a V here. Okay, so between 5 and 6, and it must be parallel. Please don't forget that when you draw a circuit, and if they ask you, it must be straight lines, always making right angles. Okay, it's not allowed to be bent to curve. 7, you have 4.5-volt battery, okay, and the light bulbs here in the circuit are identical. La 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 la. The current through the battery is 50. Okay, so in the battery it's 50. How much is it in bulb 1? How much is it here? It's also going to be 50. Why is it also going to be 50? Because the current throughout the whole circuit in a series circuit is the same. So the current here is equal to the current here. But here, when it reaches here, it goes like this. The arrows. The direction of current is always represented by arrows. It goes here with branches up, with branches down. صح? Since they're saying the light bulbs are identical, that means the current I1 here is equal to the current I2. And we know that the sum of it must be 50 because now we're only supplying 50. So if you have two identical light bulbs, they're both gonna um they're both gonna absorb the same amount of current. And since they add up to 50, that means they're equal to each other. So 50 divided by 2, that means you have 25 here, or 25 here. So 25, 25. This was an AMS question. Kirchhoff's law also came. It was heck. I remember it came in the CA. It was like this, like this, like this, like this. Junction here. X ampere, 3 ampere, 4 ampere, 2 ampere. Heck, 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 heck. Find X. Bro, just add 4 plus 2, 6. Or 6. ID 6 minus 3. You're gonna get 3 ampere. Yani, very, very stupid question. The current going in is equal to the current going out. So x plus 3 is equal to 4 plus 2. So you're going to get x equals 3. Okay, here they're saying that the current here is 1.1. The current here is 0.3. Ooh, they're asking what's the current through the bulb. In parallel, you always add up the currents. So 1.1 plus 0.3, you're going to get 0.4. Okay? To explain this using Kirchhoff's law, because they're saying Kirchhoff's law. Kirchhoff's law states that the current here branches into the current here and the current here. When you add up these two, you're gonna get the total current out here, which is 1.1 plus 0.3, 1.4. I think خلصنا. Yes, we're done. Let me see if I can remember any past questions. Not anything that I can remember. Thank you so much for watching. Good luck.